Assalamualaikum warahmatullahi wabarakatuh. My group, which is Group 8, will be presenting today lab assignment number 3 for course MAT 183, and the title will be Application of Differentiation. My group, which is Group 8, consists of the members Muhammad Danish bin Nurhan, Rahmat Johari Daud bin Abdullah, Aish Amri bin Amer, and Ahmad Alif bin Asri, which is myself. And this is the content of our presentation. We have, first of all, introduction, and then when is when will when is the time to use differentiation, then example questions and solutions, and then conclusion.
Firstly, we will talk about what is differentiation. Differentiation is the derivative of a function of a real variable. In mathematics, describe the sensitivity of the function value as output value to changes in its argument as output value. Calculus uses derivatives as a fundamental tool. The velocity of a moving item, for an example, is the derivative of its position with respect to time. It quantifies how quickly the object's position changes as the time passes.
So when is the time to use differentiation? Well, we use differentiation when there is a function, a mathematical function, and we use differentiation when we want to find the maximum and minimum value of a function. And we also will want to use function to solve problems that involves two different variables and show relation and also rate of change between the variables in that mathematical function.
Bismillahirrahmanirrahim. My name is Muhammad Danish bin Nurhan and I will solving the following questions. So this is the question and I will read the question first. An upturned cone with semi-vertical angle 45 degrees is being filled with water at a constant rate of 30 cm cube per second. When the depth of water is 60 cm, find the rate at which. So this is the questions. They have three questions. The first one, H, the depth of the water is increasing. R, the radius of the surface of the water is increasing. And the last one, S, the area of the water surface is increasing. So this is the solution. The volume V of the water in cone is given by V equal to 1 over 3 pi r cube. The cross-section of the cone is a right angle isosceles triangle, and therefore R will be equal to H. Hence, V equal to 1 over 3 pi r cube equal to 1 over 3 pi H cube. So, for the first question, we see dH per dt. Now, V equal to 1 over 3 pi H cube, and therefore dV per dH, dV over dH equal to pi H square. Hence, dH over dt equal to dH over dV times dV over dt. Then the dH over dV will be 1 over pi H square times by 30. And we will get 30 over pi H square. So, when H equal to 60, we have dH per dh over dt equal to 1 over 120 pi centimeter per second. So for the second question, we have seen that RT equal to HT. Thus, when H equal to 60, we have dr per dt equal to 1 over 120 pi centimeter per second. So, at the last questions, we seek ds per dt. The area of the water surface is S equal to pi r square. Therefore, ds over dt equal to ds over dr times by dr over dt. So, the ds over dr, we will get 2 pi r. And we get the 2 pi r when we differentiate this. And dr per dt, we will get 30 over pi r square, and we will get 60 over r. And when h equal to 60, we have r equal to 60, and so ds over dt equal to 1 centimeter square per second.
The conclusion that can we get from this topic is, firstly, the application of differentiation is used to compute the related rates or rates of change problems involving geometry formula and functions. Secondly, we can accurately count the difference in change happen using chain rule method and implicit method to solve the question given. That's all from us. Thank you and Assalamualaikum warahmatullahi wabarakatuh.